Good morning, mathematicians. Hope you guys are doing okay. Today is Tuesday, March 24th, and today we'll work on solving exponential equations. I don't know if you guys have seen this meme. I don't know, I think it's a meme. I saw it on Facebook because I'm old and I go on Facebook, talk with my family members and stuff. Anyway, so I don't know if you guys have seen this, but this is us. When I was really getting into a couple weeks ago learning about coronavirus, and I was like, oh my gosh, it's an exponential function because the graph is increasing exponentially. The rates of contagion are increasing exponentially. So, and then I was like, oh my gosh, it's so funny. When will we ever use this crap? Well, people are using it right now. So we can use it and we're going to use it. And you guys are going to have an assignment on it tomorrow. So with the data that's actually pretty recent and pretty current. So anyway, so since they don't really, I guess, them but honestly, they look kind of parabolic, right? Kind of like shape graphs. Anyway, so we're going to talk about that. If you guys are doing okay. I'm sending this to you guys. It was a PowerPoint, but I'm sending it to you as a PDF. Most of you guys were messaging me yesterday because you could not open documents to send them to you as Word documents because you guys know that I taught online for almost 5 years. Most students don't have Word, and it's easier to open PDFs, and I know that. And you can even edit them online and save them for free. So if you guys want them as a Word document, I will send them to you, but let me know. I feel like you're, for the most part, going to be okay with the PDF. You can print this out. If you do, I would print out this page because it's got a lot of color on it, and parents use it. But I printed out pages 2 through 6, which will start here. So today, get the notes saved on, you can, put them on your computer and write on them with the pen tool or whatever, like if it's a PDF viewer. Let me move my video. Like add notes, you guys can do that and you can mark on it, right? Like with the pen right here. So you guys can definitely do that. I don't know why it's not working for me right this minute. There it is. There you go. Right? So you guys can mark on it with the pen if you want. If you have a printer, you print them out, put it in your notebook, You can make them down to 80% and you can cut it out and it'll paste in your notebook. But anyway, so watch the video with me, fill in the notes. I want you guys to try to turn it into me today. I want to make sure you guys can. My kids can do it. My 4th and 5th grader can do it. They're actually getting really good at taking pictures of their work and then sending it to themselves, their email accounts. I know it's a little lengthy, or they're getting actually, I have my printer actually scans, so that's actually been faster to just scan it into the computer and then it's already there, then they just attach the work. That's actually been easier for them now. But it's good to learn technology, right? So whatever is easier for you, I really would like you guys to send it to me today. If you're having computer issues, I need to know because we don't know how long we're going to be doing this online stuff, and I need to know if you're having computer issues. I can help you. You know that. Just like I help you with a calculator, you might need help with a calculator today. I can help you with your calculator. Ask me these questions. I am here to help you. We make these videos and we sit here all day waiting for you guys to ask us questions. So please ask us questions. Particularly, I have a meeting at 9 today, so I just kind of adjusted my office hours. So 8, 10 to 12, usually I'll go take lunch and whatnot at 12 and run errands or whatever. And then I'll come back, help my kids, and then I come back and then I'm on later in the evening doing lessons and responding to emails and stuff. So we're all here all day. So tomorrow I'm going to give you guys an assignment where you guys are going to get the real data and we're going to work with it, okay? That's why we've been giving you a little bit of these videos a little bit at a time. So just real quickly, I know this is a little bit blurry, but I just liked it and it was a free image. I didn't want to pay for a different image or spend the time making one. So hopefully you guys can kind of see, you don't need to read it like verbatim, like, just kind of get the idea. So hopefully with linear, you guys remember that linear are the y equals mx plus b equations. We have our slope and our y-intercept right here. And then hopefully you guys remember that exponential, they have exponents. And they're pretty cool because x is your exponent. So that's kind of where those come into place. So make sure that when you guys are solving these out like we're going to do today, you guys are using your order of operations, exponents before your multiplication. You guys are getting better with that, but don't forget. So in this case, we're going to talk about what the variables mean. But hopefully you guys notice on this one, your y's go from 3 to 6 to 9 to 12. So hopefully you guys are noticing that this is increasing by adding 3 every single time. And when you think about the exponential, we're going from 3 to 6, which I guess could be adding 3, but then it goes to 12. So 6 to 12 isn't plus 3. And then 12 to 24 is definitely not plus 3. So hopefully you guys are noticing that it's multiplied by 2 every time. 3 times 2 is 6, 6 times 2 is 12, and 12 times 2 is 24. So that's really how the numbers get a whole lot faster, higher with exponential functions. And that's what's happening with the virus right now. It's increasing exponentially. You can see because you're to the power of every single time. So they get larger. So because we're working with exponents versus addition, right? The numbers are going to get bigger. And so hopefully you guys are also noticing that the graphs for exponential, and you guys have been starting to see them kind of look like this. And then the graph for linear is kind of off, but they're straight lines. It's supposed to be a straight line. So you can see the difference, how quickly it's scooping up. It's getting higher and higher. And that's what's been happening. I know hopefully you guys have seen some of the data coming across, and you can see like the steeper the curve, the greater the growth rate, right, of the contagion. Anyway, so we're going to talk about this in just a moment. So this is where I want you guys to just kind of mark on the screen if possible. So hang on one second. I want to go ahead and get my paper and my pencil. Hang on one sec. And then we're going to talk about the different variables and what they mean. So you guys have some questions about this. Then we'll solve a couple problems. Hang on. Okay, guys, so hopefully you were able to get this printed or get this up where you can actually write on it. So I just want to highlight a couple pieces of information from we're going to call it, I don't know if it's really a formula. We're going to use this format to plug in information that we have. Okay, so right over here, you have your y-intercept, which is that A. Really, another thing to think about is this is your initial or your starting value. So when it's at like 0. So sometimes we'll say like at the beginning of the data started at 0, right? And so it's going to increase, whatever we're talking about. I have an example that's about population. I have an example that's about bacteria. We're really only going to talk about growth today. We're not going to talk about decay. It's the same idea. It's just a smaller rate here. It's actually going in the opposite direction. But we're only going to talk about growth functions today because really when we're talking about like COVID-19 that you guys are going to work on tomorrow, the data from that, it's growing, right? So it's contagion, so it's growing. Bacteria grows. Interest rates grow. So really only going to talk about growth this week. This wasn't my plan to talk about exponential functions this school year, but because of what's going on, it's my duty as your Algebra 2 teacher to do this with you guys, okay? So anyway, so we have that, and sometimes you're going to see y, sometimes you're going to see f of x. Don't forget, and just remember that's just your output value, or whatever the output is for a certain period of time. It says over here the exponent of x makes it an exponential function. That is true because you have an exponent of x. X is generally speaking, it's usually some kind of time. Okay, so maybe like years, it could be days, it could be hours, just depends on the situation. Just whatever that the problem is set up. It doesn't really matter, just whatever you're working on. And so we talk about it's going to be like, we might call it like a rate of growth. It's kind of like slope, if you think of it like that, like over a certain period of time, how much is the population growing, or how fast is something decaying, or something like that. So rate of growth is generally what the B is. So hopefully you guys edited this and you added these changes to it. Okay, so we're going to go on to the next piece of information. I'm going to go through 2 examples with you guys, okay? See if I can do them in about 3 minutes apiece. Let's see. I talk a lot. So, all right, example 1. Kristen starts an experiment with 7,500 bacterial cells. I went ahead and set up a table right here, you guys. I just made this isn't like part of the problem, but I was like, maybe if you could see it in like a table format, it would make sense, like a table of values, right? So I just went ahead and set this up based on the data. So she starts with 7,500. That's why it's like x is 0 and the y is 7,500, right? So you can kind of think of it like a point, 0, 7,500, right? And then it says after 4 hours, so now your time is increasing from 0 to 4, right? So in 4 hours, now her bacteria is increasing to 23,000. We don't know what the rate of growth is. Obviously, it's increasing, right, from 7,500, from 7,000 to 23,000. So in 4 hours, it's increasing. So it's definitely got a rate of growth here. Write an exponential function That's what you guys are going to do. That could be used to model the number of bacteria after however many hours if the number of bacteria changes at the same rate. So this is kind of like what we did with the scatter plots last week, where we were like, okay, well now predict what it will be in 20 years, or predict what it will be in 30 years, or something like that. We're going to do the same thing. The only difference is the equation is set up as an exponential equation versus a linear. Okay, it's not going to be a straight line, it's going to be curvy, and it's going to scoop up. But we're going to go ahead and then it says calculate it after 12 hours. So now we're going to be thinking, okay, well, what is it in 12 hours? And this is the thing that we don't know right here. So we got to figure out the rate of growth so we can figure out what the bacterial cells will be in 12 hours. Okay, so let's go ahead and do step one. You guys follow along with me here. Plug in the values into the exponential formula, which are right here. We have that formula right there, don't forget. So we have y equals a times b to the power of x. Okay, so plug in what you have. You're given a lot of information. And luckily for you, we're only not given the rate of growth, which is the b. That's the part that we don't know. Okay, so we know the starting amount and we know the amount after 4 hours. So what we're going to do is we're going to go ahead and see if we can get the starting amount. And if you guys remember, the starting amount is the A, if you remember from the other slide. So at A, it was 7,500, right? We don't know our B because that's the rate of growth. That's what we don't know. We don't know how it's increasing from here to here. We don't know the rate. And we know that 7,500 was our starting amount, but we also know it goes to 23,000 in 4 hours. So remember I told you that the exponent is always time. So your time is 4 hours, and we also know it jumped from 7,500 to 2,300. Now you guys can go ahead and solve for B, and I'm going to show you how to do it. It's pretty cool. Let me see if I can change my color so it doesn't get too like crazy sloppy. Okay, so if we did that and we have 2,300 equals 7,500 times b to the 4th power, we can go ahead and solve this. You guys know you want to always get your variable by itself. So how would you get your variable by itself? How would you get your b by itself? We're going to go ahead and get rid of your coefficient right here. Divide both sides by 7,500. And guess what? You guys can use the calculators on your phones today. Okay, I won't even know. I'll close my eyes. I won't even know. All right, so anyway, you guys are going to go ahead and calculate that. I believe I already did. Maybe I didn't. So you guys are going to go ahead and calculate that, and then let me see if I have it right here. I guess I could just grab my calculator, but I worked this out. This was actually in your textbook. So whenever you do that, you get something like 3.067 equals b to the 4th power right here. So I want to erase that. Looks really messy. All right, let me go back to my pen. Okay, so now we have b to the 4th. We don't have b, because remember, we always want b, just like we want x, or we want y, or we want something like that. We only have b. So what we're going to do is we're going to go ahead and hopefully you guys remember, like if you had, let's say it was, I'm just going to write this off to the side in like a different color. Okay, remember, if you had something like b, I'll say x squared equals, in this case, 336. How would you get rid of this x squared? Hopefully you guys remember you would square root both sides, and that would leave you with x is equal to 6, technically positive or negative 6, right? So remember, if you have a square, you could take the square root, okay? Because really a square root means you're looking for two numbers that are the same. So the square root of 36 is 6, because 6 times 6 is 36. There's two 6s, okay? We're going to do the same thing over here. You guys, the button on your calculator would be something like this. Might have a Y here. It might have some kind of letter, not a number. You have one with a 2. Like if you use your iPhone, you might have a 2 or a 3 here, but that's all you guys will see. So we're going to go ahead and find this button here on your calculator. We're not going to square root both sides. We're actually going to take it to the 4th root. Okay, and it's okay. You're going to find this button. You're going to click it on your calculator. And when you do that, you should get something like 1.323 equals B. and that is your rate of growth, okay? So that's how it's increasing right here. So that's your rate, okay? So let's go ahead and do step 3, plug all values in to create the new equation. We kind of already did that. So it would be 7,500, y equals 7,500. Your rate is 1.323, and you can do this for whatever time value you want to do, whatever time value you want to calculate. So now we know that in 4 hours, the growth rate is going to be 1.323. But we want to answer the question. The question is, what would the bacteria increase to in 12 hours? So you guys can go ahead and do that. We're trying to figure out now what would the value be in 12 hours. So you can go ahead and do that. Y equals 7,500 times your 1.323 to the power of x. And your power of x is now going to be 12, because we want to know what would it be in 12 hours. So use your order of operations. You guys would get y equals 7,500 times whatever 1.323 is to the 12th power. 1.323 to the 12th power. Well, now I wish I would have brought my calculator over here with me. So if you guys were to calculate that, it would be 7,500 times, I don't know if my calculator over here has that. Let me go grab mine. Hang on just a sec. All right, guys, if you were using your iPhone and you tilted it sideways, hopefully you guys would do 1.323, and then you guys would do this button right here that's x to the power of y. I don't know if you guys can see it, but it'd be the x to the power of y button. And we would do that to the power of 12, and you would get something like 28.75, blah, 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 blah. And then you guys multiply that out, you would get something like y is equal to, I got 215,665. So you can see that at 12, the bacteria in 12 hours is going to increase to 215,665, whatever this is. Oh, cells. I was like, what is it measured by? Cells. Okay, so look over how we did this. Remember, exponents first, and then you do your multiplication. If you're going to mess up, that's where it's going to be. If you have questions with your calculator, let me know. I'm going to pause the video. I want you guys to go down to the next example right here. Example 2, it's the same exact type of problem except it has years, but we're going to go ahead and start here. So it says in 20,000, the population of Phoenix was 1,321,045 people by 2007. And I made a table here again. By 2007, it was, I really don't do a great job with boxes. By 2007, it was now 1,512,986 people. Write an exponential function that could be used to model the population of Phoenix. We're going to make the equation with the power of x, and then it says you want to know the population in 2021. So this would be next year. So in 2021, it looks like if 2000 was 0, if 7 was 2007, we want to know what it would be at 21. Okay, so this is the part we don't know. So we want to go ahead and make sure we can do this step here. So you guys go ahead and pause the video. Make sure you guys can set up your equation. Make sure you guys can solve it for B. And hopefully you guys can plug all your values in to the new equation and then finally answer the last question. So I want you guys to go ahead and set up your equation. Go ahead and pause the video and try to make this equation right here. Okay, for step 1. Okay, so hopefully with step 1, you guys were able to plug in the new amount that we have, which is the 1512986. Remember, the starting amount was 1321045. We were at 1,000,003, and here 7 years later, we're at 1,000,005, and this is 7 years later. So remember, we're going to go ahead and set it up like this. Find the rate of growth. That's your B. Figure out how is the population increasing over 7 years. How did it get this high? Okay, and that's what you do for step B or step 2. So go ahead and pause the video and see if you guys can go ahead and remember how to do this like we did on the last example, and see if we get the same thing. Okay, so hopefully you guys divided first by your leading coefficient to get the B by itself. And so hopefully you divided both sides by that 1,000,003 number. And when you did that, you would get something like 1.145 is equal to b to the 7th power. And then remember, you're just going to click on that button on your calculator that's like the square root, but there's no square out here, right? It's just a random letter, so you guys can change it on your calculator. So you hit that and then put whatever power you want. In this case, we want power of 7, so we can take the b's down to a single power of 1, because 7 divided by 7 is 1. You should get your rate of growth is 1.0196. So it's saying that this is increasing by 1.0196, okay, every time. So go ahead and plug all your values in to create your new equation. So it should look something like y equals your starting amount, which was 1321045, and your rate of growth was 1.0196 to the power of whatever year you need, okay? Now go ahead and solve step 4, which is to use substitution to calculate the equation. Remember, we're trying to figure out right now what would the population be in year 21. So go ahead and try that on your calculator. Let's see if you guys get the same thing. Okay, so last piece of the puzzle. Hopefully, whenever you guys found 1.0196 to the power of 21, you got something like 1.5 on your calculator. It's not exact. 1.503, I think it was. Multiply that times your 1,000,003 number, and you guys should end up, I'm going to just kind of have to write it over here, that your population predicted in 21 years, or in year 2021, would be something like y equals, I got 1,009,000. 1,985,839. Oh no, I can't get a 9 over there. There's the 9. So 1,985,839. I'll write it over here. 1,985, 839. You just want to round up because you can't have like a seventh of a person or something like that. So that's what the population would be in 2021 prediction in Phoenix. Okay, so write that people in 2021. So you're making a prediction. Okay, that's your answer. That's how you do it. So just remember, you got to have some funky buttons on your calculator. You got to push, and that's really it. It's really the only difference is the funky buttons on your calculator, but y'all can do that. You have, you can also use Desmo's scientific calculator if you need it, not the graphic one, but the scientific one. Okay, so you guys can always record and pause the video. Don't forget, your assignment today is just to send me your notes. Find a way to send them to me. I don't care what method you want to use, but you have got to try to find a way to send me your notes today. Yesterday, I kind of let you off the hook. I just want to make sure you guys were watching the video. Today, I need to make sure that you took notes. Okay, so send that to me today before 8 o'clock, and you guys are all good to go. Tomorrow, you'll have a new assignment with this material. So thank you for watching the video. Thank you for doing some math, and have a fabulous Tuesday, March 24th. I'll talk to you guys later. Don't forget to see me in my office. Bye, guys.